So now coming to classification of carbohydrates. Okay, carbohydrates are broadly classified into three categories. One is monosaccharide, second one is oligosaccharide, third one is polysaccharide. And a few of the textbooks they have classified into four types. It's up to you. I mean, like how you take the classification. Okay, few textbooks they mentioned monosaccharides, disaccharides, oligosaccharides and polysaccharides. But here I have classified carbohydrates into three types. Okay. So monosaccharides, that means these monosaccharides have only single sugar unit. Okay. And oligosaccharides, they have 2 to 9 sugar units. And polysaccharides, they have more than 10 sugar units. So this way we can classify carbohydrates. So once again repeating, carbohydrates are broadly classified into three types: monosaccharides, oligosaccharides and polysaccharides. So depending upon the number of sugar units. So what it indicates, monosaccharides which are having single sugar unit, they comes under monosaccharide category. The carbohydrates which are having more than, that means 2 or up to 10 sugar units, they comes under category oligosaccharides. If the sugar units are more than 10 in number, they comes under category polysaccharides. So in this table, I have broadly classified carbohydrates into three types: monosaccharides, oligosaccharides and polysaccharides, and I have mentioned the sub classification of particular carbohydrate also. Okay, so monosaccharides, again they sub classified into two types. So based on what category, based on what basis? Based on functional group, based on number of carbon atoms. Monosaccharides again classified into two types. Okay, on what basis? One is based on functional group and other classification based on number of carbon atoms. Okay, and if you are coming to the oligosaccharides, okay, based on the presence of number of sugar units, again they have classified into three types: disaccharides. The name itself you can tell, di means 2 sugar units present in disaccharide; trisaccharides, 3 sugar units present in trisaccharides; and tetrasaccharide means 4 sugar units. Okay, so concerned examples also I have mentioned in the table. Polysaccharides, poly means many sugar units. So before itself we have described. Okay, so many sugar units, that means more than 10 sugar units any carbohydrate contains, means it will come under category polysaccharide. Okay, so polysaccharide again classified into two types based on the type of sugar unit. Okay, based on the type of sugar unit, polysaccharides again classified into two types. One is homopolysaccharide, other one is heteropolysaccharide. In homopolysaccharides, the sugar units belongs to same group. Okay, so suppose monosaccharide is a single sugar unit, right? So we have several examples. Monosaccharides, glucose is there, galactose is there, fructose is there, mannose is there, right? Okay, so in homopolysaccharides, suppose example of homopolysaccharides, starch, glycogen, inulin, okay, and dextrin is there. Okay, so starch is made up of repetitive units of glucose. Okay, starch is made up of repetitive units of glucose. If starch is made up of 1000 molecules, okay, all these 1000 molecules are of glucose. Okay, no other monosaccharide. It is made up of only purely glucose. If you are talking to inulin, okay, this inulin is a polymer of fructose. That means if inulin is having 100 molecules, okay, all the 100 molecules are fructose. Okay, and glycogen is also same. All the molecules present in glycogen are glucose. But this is not similar in case of heteropolysaccharides. Heteropolysaccharides, the number of sugar units and the type of sugar units differ. Okay, suppose if you take examples like hyaluronic acid, heparin, chondroitin sulfate, keratin sulfate. Okay, if you take example of chondroitin sulfate, okay, if chondroitin sulfate is made up of 100 molecules, okay, the first two molecules will be glucose and the second two molecules will be galactose and the third or like next few molecules will be fructose. So repetitive different sugar units. Okay, repetitive different sugar units will be present in heteropolysaccharide. Okay, so these are the things about classification and nomenclature. So let us describe one by one. Okay, chemistry of carbohydrates. Okay, chemistry of carbohydrates. In this category, we will discuss about monosaccharides. Okay, mono, what it indicates? Mono means single, saccharide means sugar, single sugar unit. Monosaccharide consists single sugar unit. The prominent example for this monosaccharide is glucose, and this point also I can add here. These are the simplest sugars. Monosaccharides are the simplest sugars which cannot be hydrolyzed further. Okay, you cannot get any further simple. Okay, these are only the simplest form of sugars. So in previous slide only we have explained, how monosaccharides are classified again. Okay, these monosaccharides are again classified into two types. Okay, based on the functional group, based on number of carbon atoms. So based on a functional group, you have aldoses and ketoses. If the compound, the monosaccharide is having functional group as aldose, you can give example glucose. For ketoses, you can give example fructose. So again, depending on the number of carbon atoms, okay, if monosaccharide is having 3 carbons, that is triose. If the monosaccharide is having 4 carbons, that is tetrose. If the monosaccharide is having 5 carbon, that is pentose. If the monosaccharide is having 6 carbons, that is hexose. If the monosaccharide is having 7 carbons, it is known as heptose. Okay, we will see the examples and the importance in the next slide. So now we will see the example of monosaccharide what I have classified based on number of carbon atoms. Okay, so 3 carbons means triose. The example what I can give is glyceroldehyde. Okay, the best example here I have clubbed the two classifications. Okay, one is number of carbon atoms, other one is functional group. Okay, if the monosaccharide is having 3 carbons with the functional group aldehyde, example I can give glyceroldehydes. Okay, the same time the monosaccharide which is having 3 carbons and is having functional group ketose, okay, I can give example dihydroxyacetone. Okay, and similarly if a monosaccharide is having 4 carbons and a functional group aldehyde, the example I can give erythrose. Okay, and the monosaccharide which is having 4 carbons and the functional group ketose, I can give example erythrulose. If the monosaccharide is having 5 carbons, known as pentose, with the functional group aldehyde, that is known as ribose and xylose, examples I can give. And pentose with the functional group ketose, I can give example ribulose and xylulose. And hexose, that means the monosaccharide which is having 6 carbon, known as hexose, with the functional group aldehyde, that is known as glucose and galactose. 2 example I can give here. Mannose also I can add up. And if with the hexose with the functional group ketose, it is known as fructose, example. And heptose with the functional group aldehyde, glucoheptose, and with the functional group ketose, pseudoheptulose. Okay, now we will see the importance of these substances. Okay, so trioses we have given example for aldehyde, aldoses and ketoses, right? So importance of these trioses in biologically, okay, that is they are intermediates of glycolysis. If you go through the pathway of glycolysis, there you will get this glyceroldehyde 3-phosphate and dihydroxyacetone phosphate. Okay, and glycerol, this glyceroldehyde converted to alcoholic form glycerol, and this is the starting substance for synthesis of lipids, and they will store in the adipose tissue. And coming to the 4 carbon compound monosaccharide, tetrose, erythrose. Okay, these are also intermediates of carbohydrate metabolism such as HMP shunt, hexose monos phosphate pathway. Okay, and pentoses D-ribose, uttermost important pentose sugar in the body which is required for nucleic acid formation. Without DNA there is no cell regeneration, right? So without ribose there is no DNA and RNA. And coenzymes such as I already mentioned, some of the water soluble vitamins such as riboflavin, it is also required D-ribose in the structure. Hexoses, glucose importance we know, fructose. So some of the like cane sugar or like some fruits contain fructose. So but we cannot utilize the fructose. Fructose can be converted to glucose and it can be utilized for energy production. Similarly in case of galactose also, galactose which can be converted into glucose and it can be produced in energy. Same mannose. Mannose rather than in production of energy, it will be used in formation of heteropolysaccharides for structural aspects. So now coming to oligosaccharides. Oligosaccharides by definition, the number of monosaccharide units in this oligosaccharides will be more than 2 to 10. I mean the limitation up to 10. If a carbohydrate contains number of monosaccharides 2 to 10, that category will be called as oligosaccharides. And how these monosaccharides are joined together. Okay, here I am showing if glucose 1, glucose 2, glucose 3, like this different monosaccharide units are there. So how they will be joined together? They are joined together by glycosidic linkage. Okay, one monosaccharide to other monosaccharide joined together by a linkage called glycosidic linkage. Okay, this way oligosaccharides and polysaccharides, they are together. Okay, all these molecules are together in these compounds. Okay, on hydrolysis, so suppose if I hydrolyze a oligosaccharide, suppose example disaccharide, I will get 2 monosaccharides. When disaccharide undergo hydrolysis, it produces 2 monosaccharides. It produces 2 monosaccharides. Okay, again they are subdivided into types based on the number of monosaccharides they have. Okay, oligosaccharides further classified based on the number of monosaccharides they do have. Okay, one is disaccharide, that means 2 monosaccharide units are there. Trisaccharides, 3 monosaccharide units. We'll see the examples later. Tetrasaccharide, that means 4 monosaccharide units. Pentasaccharides, 5 monosaccharide units. So this way oligosaccharides are subclassified. So classification and examples in this slide I am showing. Disaccharides, that means 2 sugar units, 2 monosaccharide units. Okay, example I can give maltose, which is present in cereals and then barley. Okay, and lactose, the milk sugar. Okay, the lactose, where it is present? It is present in milk. That's why it is known as milk sugar. And sucrose, sugar cane, which were present in table sugar, what we are using in daily table sugar. In that sucrose will be there, which belongs to category disaccharides. Okay, and trisaccharides, raffinose, tetrasaccharides, stachyose, pentasaccharide, verbascose. So all these are other other type of oligosaccharides which has have less significance. Raffinose, stachyose, verbascose, all these find in cabbage, cauliflower. Okay, in the plant vegetable sources. Polysaccharides. Polysaccharides are the compounds which are having many monosaccharide units. Okay, many monosaccharide units. Again, based on the type of monosaccharide unit, they have classified into 2 types. One is homopolysaccharide, other one is heteropolysaccharide. Homo means same type of sugar unit. Okay, homo means same. If this type of polysaccharide containing same type of monosaccharide, there comes under category homopolysaccharide. If different types of monosaccharide units are present in the polysaccharide, those substances will come under category heteropolysaccharides. So in general, speaking about the features of polysaccharide, they contain more than 10 sugar units. Okay, generally polysaccharide should have more than 10 sugar units, and they are the molecules with high molecular weight, and they are sparingly soluble in water. Okay, in cold water and all they cannot soluble. When heating and in some acidic solutions, they are easily soluble. They are called as glycons because of their high number of sugar units. They may be linear, that means there are number of n number of monosaccharide units are there. So that's why they may be straight chain. Okay, or they might be branch. In tree branch, you can compare this with the tree branches like this. Okay, so linear, straight chain, this is branched. Compared to monosaccharide and disaccharide, polysaccharides are not sweet in nature. Okay, all the monosaccharides little bit sweet in nature, like glucose, galactose, okay, fructose, and in disaccharides sucrose. But polysaccharides, they are not sweet in nature. Okay, and they do not exhibit any properties like monosaccharides and disaccharides, because all the functional groups are involved in glycosidic linkage. So they don't have any free functional group to perform the chemical or physical functions. So again here I am showing the classification of polysaccharides and the examples. Homopolysaccharides, you have 3 examples: starch, glycogen and dextrin. Inulin also you can count here. Okay, otherwise heteropolysaccharides, again we have examples: chondroitin sulfate, keratin, heparin, dermatan sulfate, hyaluronic acid. So all these comes under heteropolysaccharides. So glycosaccharide is nothing but when sugar unit attached to single amino acid, okay, any polysaccharide which is attached to a single amino acid, it can be termed as glycosaccharide.